This is pre-algebra lesson 4-5. Account for all possibilities. Now in math, some problems require looking at all the possible solutions before you can try to figure out what the actual solution is. So organizing data into a list or a diagram can be very helpful to try to keep track of all the information that you have. Let's take the following example. Aaron, Chris, Maria, Sonia, and Ling are on a class committee. They want to choose 2 members to present their conclusions to the class. How many different groups of 2 members can they form? So we have to think about a few things here. The first thing we have to think about is, what are we asked to find? Well, we want to know the number of groups of 2 that can be formed. And there are a total of 5 people, and 2 people will be presenting. So one way to solve this problem is to draw a little bit of a diagram. Okay? We can draw a diagram that looks something like this. If we start with Aaron. Okay? Aaron could be paired with Chris, or Aaron could be paired with Maria, or Aaron could be paired with Sonia, or Aaron could be paired with Ling. Okay? So those are the different pairings we can have there. So Aaron's the first person. Now we're going to go talk about Chris. Now, Chris was already paired with Aaron, so we can't repeat that pairing, because right back here we had Aaron paired with Chris. So Chris paired with Aaron is exactly the same 2 people. So we can skip having Chris paired with Aaron, and of course he's not going to be paired with himself. So then Chris can be paired with Maria, Chris can be paired with Sonia, and Chris can be paired with Ling. Okay, so those are the pairings for Chris. So we have the pairings for Aaron and the pairings for Chris. Now we can think about the pairings for Maria. Maria was already paired with Chris, and Maria was already paired with Aaron, so we're not going to pair her again with those same people. So Maria can be paired with Sonia, and Maria can be paired with Ling. And last but not least, we have Sonia. Sonia was already paired with Maria, Chris, and Aaron, so the only person left for Sonia to be paired with is Ling. And obviously, by the time we get to Ling, Ling hasn't been paired with everybody else. So if we count this, we can see that we have 10 different pairings. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If we just look at this and figure out the pairings, we have 1 pairing, 2 pairings, 3 pairings, 4 pairings, 5 pairings, 6 pairings, 7 pairings, 8 pairings, 9 pairings, 10 pairings. There's 10 total pairings. But if we look to try to see a pattern here, you might look at this and say, Aaron was paired with 4 people, Chris was paired with 3 people, Maria was paired with 2 people, and Sonia was paired with 1 person, which means each successive list had 1 fewer person to pair with. Okay, so that's a pattern we can look for, and we can say, that's kind of interesting. So we know that there are 10 pairings. Okay, so there's 10 pairs that can be formed. Let's look at this same problem, but in a slightly different way, or a similar problem. Okay? Let's look at a similar problem here. Let's say we have coins. Everybody likes money. Let's say we have 3 coins that are tossed, a penny, a nickel, and a dime. What is the possibility of getting exactly 2 heads? Okay, when I flip a coin, it either comes up heads or tails. But what's the probability that I'll have 3 coins in my pocket, I'll throw all 3 up at the same time, and when they land, I'll get exactly 2 heads. Not at least 2 heads, but exactly 2 heads. It doesn't matter if the head shows up on the penny and the nickel or the dime, or the penny and the dime. As long as I get 2 heads, we need to figure out, what is that possibility? Well, let's take a look at this. I am going to draw what some people refer to as a tree diagram. It looks like it's called a tree diagram because it kind of branches out. We have 3 coins. We have our penny, we have our nickel, and we have our dime. Now, if I tossed my penny up in the air, it could either land with a head or it could land with a tail. Let's say the penny landed head side up first. Now, if I tossed my nickel up, my penny can be paired with the nickel. When I toss my nickel up, my nickel can come up with a head, or my nickel can come up with a tail. So that penny could be paired up with a nickel and head, or it could be paired up with a nickel and tail. Now let's just say that my penny, look, when I flip my coin upside down, It flipped up, it flipped, and when it landed on tails. Now, the penny landing on a tail could be paired with the nickel that landed on a head, or the nickel that landed on a tail. Now, let's go to the third coin, a dime. If my first penny, if I flipped my penny and it landed on heads, and I flipped my nickel and it landed on heads, my dime could either land on a head, or it could land on a tail. Notice how it's branching out, hence why we follow a tree diagram. If my penny landed on a head, but my nickel landed on a tail, my dime could either land on a head, or my dime could land on a tail. If my penny landed on a tail, and my nickel landed on a head, my dime could land on a head, or my dime could land on a tail. Or, my penny lands on a tail, my nickel lands on a tail, my dime lands on a head, or my dime lands on a tail. So, what are our possible outcomes here? Let's take a look at this. If I go right along my trail here, if I follow this pattern here, okay, I'm getting a head, and a head. If I follow the next pattern, okay, I'm just going to show you this, I could go, this goes to head, this goes to tail. So here, this would go head, tail. See how that works? If my penny comes up head, my nickel can come up tail, and my dime can come up head, or my penny can come up head, my nickel can come up tail, and my dime can come up tail. Or, my penny comes up tail, my nickel comes up head, and my dime comes up head. My penny comes up tail, my nickel comes up head, and my dime comes up tail. Or my penny comes up tail, my nickel comes up tail, and my dime comes up head. Or last but not least, the penny comes up tail, the nickel comes up tail, and the dime comes up tail. So if we look at this, what is the possibility of getting exactly two heads? That means I have to have two H's and a T. It doesn't matter what order they are. Well, here's two H's and a T. Here's two H's and a T. And here's two H's and a T. So there are three possible ways in which I will get exactly two heads. What is the possibility of getting exactly two heads? Three ways. There are three ways that I can get exactly two heads. And this is called exploring all the possibilities. And sometimes it's just really, really helpful to make a little list. Okay? For example, a lot of times you'll get things like, I have two t-shirts and two pairs of pants. How many different outfits can I make? How many different ways can I wear my two t-shirts or my two pairs of pants? You could make a tree diagram like that, and you could set it up that way. Or you could make a little branching diagram like I did with the people, and you could do a pairing like that. But all this does is help organize your material in a way that is easier for you to follow, and therefore you'll understand how to do this. This is called accounting for all the different possibilities.